Hi, Mary.
Hello?
Hi, hello.
I have to figure out the sound.
Can you turn off one of the screens audio if there are two different computers?
Yeah, I know, because I'm using two angles.
Yeah. Just use one sound only from one computer.
Okay. I mean, I have my phone muted right now.
Muted.
Oh, I think I know what to do. Okay, is that better?
Let's try.
Yeah, does it work?
Yes, it works. Perfect.
Okay, cool.
Okay. So
Yeah, I'm ready to start.
we are already online. And yes, you can start. Thank you for being with us, Mary. Welcome, everybody. So it's yours.
Ekmel, do you want to give a brief introduction of what the festival is about and the context of this workshop?
Oh, yeah. Okay, sorry. Okay, let me do that. Sorry for that. I cannot turn on my camera. But yeah, this is amberNetworkFestival. It is an 10th edition of Amber Festival in a different way, which we had run from 2007 and 2015 as Amber Festival in Istanbul. Now this is in collaboration with Oyun. Here we are running the 10th edition in a way, but in a different format, which is now a network festival with participation of Network Nodes, New Media Society from Tehran, Bob from Khartoum, DAH Project from Shiraz, Kaun Active from Casablanca, Sharaban from Baalbek, Adef from Cairo, Daraj from Izmir, and Amber Platform from Istanbul. And therefore, it is a collaboratively created festival. And this is one of our creation now, and we are gonna have a workshop on bioart with Mary Maggic. Yeah, thank you.
Thank you everyone for joining. So just before we begin, I just want to put out a little disclaimer. So originally the workshop was planned to be live. So I had a list of 10 people that I invited to my flat, and we're in my flat right now. Unfortunately, yesterday I received some news that a teacher from my child's daycare is tested. So my child might be positive, we're not sure, so that means I might be positive. So I decided to cancel the live portion of this workshop and just do the online version. So that's why I'm sitting here by myself in my flat. But I have everything prepared, and I think this will still be a fun and interesting workshop for the online audience. So as you can see, I have two cameras set up right now. There's one on my computer where you can see me speaking. And then the second camera is right here where my finger is waving. And this is so that you can see what my hands will be doing. Okay, so I will first begin the workshop with a presentation, because I want to give a context for the research of this workshop, the hormones, and kind of the history of how it all began. So I'm going to share my screen. Can someone tell me how to share my screen?
Yes, 1 second.
Mm-hmm.
Now you will see one more button next to the camera.
Aha, got it.
Mm-hmm.
Okay. So, welcome everyone. Can everyone see my screen? You should see like this rotating icon. Yeah? Hello, hello, hello. Anyone there?
Yes, we see it.
Okay, great. Cool. So, hi everyone. My name is Mary Maggic. I am live streaming this workshop from my flat in Vienna. And the title of this workshop is called Becoming with Funghi. And I'm going to give a brief introduction of the open source estrogen project that kind of led into this estrofem biohacking mobile lab thing that I've been doing since 2015. And I would say that the Funghi protocol is the most recent hormone hacking protocol that I've been working with. And so, yeah, let's begin with the presentation. So, first of all, what are hormones? What is estrogen? What is testosterone? These are very important questions to get through before we start the workshop. So in 2015, I was asked the question, you know, is it possible to make hormones in the kitchen? And this was a very intriguing question because it made me think about all the ways that our bodies are already managed and controlled and also polluted by industries, by corporations, by institutional gatekeeping. So when we think about hormones, what are they actually used for? So you see on the screen, this is actually, you know, when you type in estrogen into Google image search, these are all the images that pop up. So this is actually just a screenshot. And so you can see that our main relationship with hormones is primarily through the pharmaceutical industry. So you have products that are for contraception, so birth control pills. You have pills for hormone replacement therapy. If you're transitioning from male to female, then you would take HRT. So you see some images of pills there. But then around all of this, and then you also have pills for menopausal symptoms. So aside from all this, you also have lots of images of femininity. So you have like larger breast size, smoother skin.
Maybe
Yeah.
you can switch the image, the page.
Switch the page.
I mean the presentation.
Oh, you
We
don't
are
see
still
it?
seeing the first page.
Really, you don't see the images of estrogen.
No.
Oh,
Yeah, the
that's really weird
first
because,
page is selected.
huh? How do I fix this? Okay, I just stopped my sharing. Let me try again. That's so strange. Does it work now? Do you see a different slide? Hello, hello, hello?
Same first page, the logo.
Huh. How about now? Still the same?
Yes.
Okay, so
Just,
I'm
just,
not really sure how to fix this because on
just,
my
just.
computer,
No, okay. Now it's changed.
now
But
it's changed.
fourth one.
Okay, then
Go back.
how about now?
Yes. Now it's okay.
Okay, so it looks like I'm not able to play the slides, so then I will just do it manually. Okay. Okay, cool. So continuing on, so this made me think that the hacking of hormones is not only the techno-scientific hacking of hormones. Like it's not just about reading these scientific papers and figuring out how to do them in real life, in the kitchen, or on the citizen level. I think that hacking of hormones also has to do with hacking these ideas of gender and sex and sexuality. Because in my research, I realized that, estrogen basically codes for femininity and testosterone codes for masculinity. And so I think part of the job as hormone hackers is to also hack these gender constructs. So as I continued on in my research, I became really fascinated by the fact that hormones are already everywhere in the environment as a state of toxicity. So, for example, petrochemical, pharmaceutical, and agricultural industries, these are the main industries of capitalism that are responsible for polluting our planet. So to give some examples, the molecule BPA, for example, this is a very, very common plasticizer. So the petrochemical industry actually was already playing around with possible uses of BPA already back in the 1930s. And then they were testing BPA for their estrogenic effects. So basically, we knew that BPA had estrogenic effects back in 1930s. So you can say that we've all been queering since the 1930s. So this is quite a big phenomenon. There's a really great writer and theorist named Rob Nixon who wrote his book, Slow Violence and Environmentalism of the Poor. And he actually compares this toxic pollution problem, let's call it endocrine disruption, or let's call it, let's go with endocrine disruption. So this endocrine disruption phenomenon, he compares it to climate change because it's incredibly slow process. It's very difficult to perceive. You know, it's not like a big bomb dropping on the country or something. You can see those catastrophic events, but with the endocrine disruption, with the hormones everywhere in the environment, it's much harder to perceive. It's much more invisible. And so I'm framing this as a kind of molecular colonization. And the reason why I say that is because it brings up the question of, if we are molecularly colonized, then how do we go about decolonizing ourselves? So, so why is this happening? Why do all of these industrial chemicals affect our bodies and bodies of non-human species? So if you look at the image here, you look at the image here,
like this,
the molecule, yeah.
later, because before it was, you were just looking at half of the screen.
Yeah, sorry about that.
Don't worry.
Okay, so if you look at this image here, the molecule on the outside, the green one, this is the estrogen receptor. So this is a protein. It's very complex and it's also very ancient. So what I mean by ancient is that basically all of the animal taxa that we have, if you look at taxonomy of all organisms, all organisms with a vertebrate we all have the same estrogen receptor. So this receptor is going back, you know, many years ago, many ages ago, evolved from very primitive organisms. And if you look, and another thing about this receptor is that it's highly promiscuous. So if you think about, let's say the receptor is a lock. Okay, so this is the lock. When a lock is very promiscuous, it means that, you know, many different keys can go inside this lock. And the opposite would be selective, which means that, you know, maybe only one key fits into the lock. So this receptor being highly promiscuous is one of the main reasons why so many of these molecules are communicating to the receptor. They're binding into this pocket, and it's causing some kind of metabolic pathway. It's activating some kind of metabolic pathway. There's two main ways that endocrine disrupting compounds are affecting our body. One way could be that here's the endocrine disrupting compound, or let's say here's the xenoestrogen. The xenoestrogen, when it binds into the receptor, it's basically blocking it. It's blocking that space that a natural estrogen would come into. So, which is the black molecule that you see in the image. So that's an image of the natural estrogen that we produce in our body. So when that's blocked, then that means, you know, your body cannot receive that main function that the estrogen would be giving. So, I just want to clarify that these hormones like estrogen, testosterone, progesterone, you know, I think we always see them as, you know, the reproductive hormones or like the sex hormones, but actually these hormones, they're in charge of so many other functions in the body that goes way beyond just reproduction. So that's why if anyone has ever had experience with taking birth control pills, you just experience so many other side effects. Like some people gain weight, some people have grown more body hairs, some people actually lose weight, or they have like their metabolism is messed up, or they have some mood swings, or, you know, there's so many other side effects, and it's because estrogen is connected to so many basic functions in the body. So and because the receptor is so ancient and it's shared by so many organisms, that's why you also hear stories of the frogs and the fish. They're also undergoing these changes, these queerings, which I will go into a bit later. So here's the next slide. Okay. So I mentioned before, it's petrochemical, agricultural, and pharmaceutical industries that are really causing these chemicals to leach into the environment. And we're basically at the point of no return. I mean, we're finding molecules like PCBs in the Marianas Trench, which is the deepest part of the Pacific Ocean. So there's really no organism that is immune to the effects of these endocrine disrupting compounds. And as I mentioned before, the effects they're a wide range. It's not only the reproductive effects. I mean, they do cause some rare reproductive cancers, testicular cancer, cervical cancer, things like that. But it's also responsible for early onset puberty in girls. So girls are starting their period when they're 9 or 10 years old, maybe even 8 years old. We also hear from men that the sperm count has dropped more than 50%. And this is a statistic for European men, so I'm not really sure about the rest of the world. Could be higher percentage in Asia, for example. So, so it's really linked to a lot of different effects that we're starting to see more commonly today. And part of my research is I'm also interested, as an artist, the kind of cultural discourse that we have around endocrine disruption. Because you're going to see, I'm going to use the word queer a lot today. And that's kind of my attempt at reclaiming this word, because it traditionally was used as a word of violence. But what I mean by queering is that we are all bodies that are disobedient. We're all a bit deviating from the norm. And so what really fascinates me about this research into hormones is that at the same time, we're seeing how normativity is defined. So this is another thing that that we're trying to hack. Like, as we're hacking hormones, we're also hacking these social ideologies of how normativity is defined. So as an artist, I think it's super important to be critical of science, of technology, of the authority of science for defining normativity. Because, if everyone is living in this polluted landscape, and everyone is coming in contact with these plastics, with these endocrine disrupting compounds, then arguably you can say that every person has a queer body. So it really begs the question of, what is normativity, and how can we as citizens start to redefine normativity in a way that we're not recreating those oppressive structures that we see today. So next slide. Just as the body can be stolen, it can also be reclaimed. So now let's go into some hormone hacking. So there's lots of ways to describe my practice. There's DIY, do it with others, biohacking, freak science, estrogen geeking. But my favorite term is public amateurism. And I'm actually borrowing this term from an artist named Claire Pentecost. And so she defines public amateurism as the process of learning and doing and failing in the public sphere while removing the hierarchy of the expert. So for me, it's really interesting to learn hormone hacking from other hackers versus like learning it in a classroom, in a biology classroom in your university, for example. Because I feel like these spaces, like this space that I've created here in my flat, this is really going against the status quo. And so you're basically creating an environment where you can create your own subjectivities, your own fictions, your own ways of knowledge production. So this is very important here. So I'm part of Hackteria Network, open source biological art, and I joined this network back in 2014. And since then, I got really into the process of Workshopology, which is like it's like the science or the practice of workshops itself. So when I do a workshop, it's not just like the same workshop every time, but I try to make it like a prototyping process. So each workshop can kind of evolve on its own, or a workshop can change based on the local context that you're giving the workshop. So there's always like a different dimension that you add to the workshop. And then this is in itself like a form of knowledge production. So it's kind of like a really meta practice. And I'm also super inspired by the trans hack feminists and Gina Punk Lab. I actually collaborated very often with Paula Pin of Trans Hack Feminists, and they do amazing work like DIY gynecology, how to 3D print your own speculums and attach a webcam so you can take pictures of your cervix and diagnose your cervix that way if you have some kind of HPV virus or something. It's very, very interesting work, and it's really about circumventing the clinic and the doctor and getting to know your own body. So I think this is really groundbreaking work. And I also want to shout out to Sub Rosa, which was a very, they were very active in the 90s in this kind of cyber feminist movement. And they did a lot of projects where they were interfacing with the public, setting up these kind of performative situations where you can really start to deconstruct the discourse, the cultural discourse with biotechnology. And I'm also super inspired by the projects, the Critical Art Ensemble, very active in the 90s and 2000s. Project that they did called Molecular Invasion was super inspiring for me, because what they did was they basically showed that you could take a transgenic organism like the soybean crop from Monsanto, you know, the one that's responsible for all the fucking monocultures that we have around the world. You can take this crop, this organism, and you can actually reverse engineer it, and you can use it for social resistance. And so this was like super groundbreaking at the time, like in 2002, like just when the public discussion about transgenics was just beginning to happen. And from their chapter, they wrote this 7-point plan for transgenic production and cultural resistance. And I decided to write my own 6-point plan for hormone clearing resistance. I'm not going to say every single point. It's kind of long. You can feel free to take a screenshot of anything that you see today. But I do want to read the last point, which is number 6. Consider the microproformity of hormones as an agential power of not only molecular colonization, but also of molecular collaboration. So what do I mean by this? So, you know, I think that, yes, we do live in this molecular colonization where these hormones are everywhere, it's ubiquitous, it's all pervasive, there's no way to escape it. But at the same time, you know, this is the state of these organisms, I mean, of these molecules. You know, they're openly available, they're everywhere, which means that they are readily available to hack. You know, it's like, to me, that's kind of what I see the term open source and open source estrogen meaning, because these molecules are everywhere, and so they are free for us to collaborate with. So it's not that we're trying to, you know, fight these molecules like they're the enemy, but actually they're part of our world, and therefore they're part of this responsive environment that we're a part of as human beings. So I'm going to now talk about some earlier protocols. So the first protocol that I ever explored was actually using yeast biosensors. So, so going back now to the initial question of how to make estrogen in the kitchen, this is actually very, very difficult, very, very difficult, especially if you're like an independent artist like myself and I don't have a lot of institutional support. It's very, very difficult. And so I decided to maybe try an easier project, which is detection. So if I'm not able to make estrogen, then maybe I can detect it. And so in a traditional lab setting, I actually worked as an environmental chemist for a very short 3 months. And basically, they're using these huge machines called like gas, what is it called? GCMS, gas chromatography mass spectrometer. So these are like huge machines that are basically, they have a database of all the molecules that they know to check. And so when you put a sample into this machine, they already know what they're looking for. And then they just show you in these peaks of what the molecule, what is present in the sample. So with the biosensors, they're actually turning yellow in the presence of any molecule that binds to estrogen receptor. So how does that work? So basically these biosensors, I inserted a plasmid into these yeast that contains human estrogen receptor. And so you can see the yeast as sort of extensions of our bodies. So when the yeast are turning yellow, then I know that that molecule that I just tested is a xenoestrogen that binded to the receptor. And I have the same receptor, so I know that molecule would bind to my receptors if I ever came in contact with that molecule. So this was super, super revolutionary for me, because like for the very first time, I could actually visualize that process of the molecule binding and communicating to the receptor. You know, it was like, whoa, like this is what's happening at the molecular level. And then here's an image of my kind of like yeast lab, because I did a lot of workshops around the world, so I traveled a lot, and so I tried to make my whole workshop like mobile. So I had this suitcase and I packed everything that I needed, and I tried not to get caught by airport security, but everything worked out. I'm not in jail. And then the next protocol is solid phase extraction. Okay, so let's say you want to test your river if it has any estrogens. So like a sample from a river is like super, super dilute. So you need a process to concentrate the hormones into a smaller quantity. So this is basically more of like a hardware project. So you take like peristaltic pump like this. So this is like a mini peristaltic pump. And you have an input. Okay, so this is the input. And the input would go into your water sample. So let's say this bottle right here is like a river sample that you just collected. Then the other side, the output, would of course go into this filter. So these filters, they're kind of special. It's not the easiest thing to find if you're not part of an institution, because you have to order them from like a lab supply company. But I have like a limited quantity that I was able to collect from past workshops. And so these filters are called C18 cartridges, in case anyone wants to try to look for them on eBay or something, but they're called C18 cartridges. And this white thing inside, that's a filter. So that white thing creates an environment for the hormones that they really like. And so that's why when you're trying to concentrate estrogens, they're all going to get trapped in that white filter tip. And so you can see in that image, the filter tip on the right side of the screen is like super dirty. That's because we ran a river sample through it. So it's trapping all of those toxicities in there. And then we have the urine hormone extraction workshop, which I just did a couple weeks ago in my flat. It was super fun. We just used cigarette filters and silica gel, and we extracted a bunch of hormones from our urine. I have a tube right here I can show you. So this is from the workshop a couple weeks ago. So these are actually hormones that are dissolved in methanol. Methanol is a very good solvent for hormones, probably the best if you compare it with isopropyl alcohol or ethanol. I would say that methanol is the best solvent for hormones. And so this is what the participants went home with. They went home with their hormones dissolved in methanol. And after this step, they were instructed to keep it open and to just let the methanol evaporate. And once that's evaporated, you get this, I have to go grab it actually. You get this brown sticky substance. Okay, I can show you on the screen. We have this brown sticky substance right here. And those are the hormones. And it's not only estrogen that got isolated, because that would be incredibly difficult. It's actually like estrogen, progesterone, testosterone. It's like also stress hormones. There's also melatonin. So it's a really big collection of all of these molecules that are classified under steroids. And then here's the image that I skipped before. This is an image of my extraction lab. And on the left-hand side, this is kind of like the setup for the urine hormone extraction. So there's a glass bottle that we just like hacked from, I don't know, from after you finish a bottle of schnapps or something. And then on the right-hand side, these are a series of peristaltic pumps that I kind of just wired into a tin box with knobs so you can control the intensity. And yeah, so that's the extraction lab. And then we saw the hormones. And then this is a set of images from what the workshops look like. So I've done a lot already, and they're all very different, all from people of different backgrounds, different ages, from different parts of the world. And one thing is always the same, which is it gets so fucking messy. And I love the messiness. I think this is part of the non-institutional practice of science. You know, it's like we're not trying to reproduce those like white cube sterile conditions that we see in the laboratory and also the gallery. But no, we're trying to perform science in other ways, in alternative ways. And finally, we come to the last protocol, which is the one we're doing today, which is becoming with Funghi, the bioremediation of toxicities. So I'm going to go into the history of this a little bit. So back in 2017, I did a group residency with Paula Pin from Unipunk Lab, and also Ryan Hammond, who is an artist doing a project called Open Source Gender Codes, which I would love to share with y'all because it's actually a really cool project where they're trying to create a source of estrogen that is coming from either plants or yeast. So this is kind of answering my initial question in the beginning, which is like, how do you make hormones in the kitchen? Well, Ryan's project, Open Source Gender Codes, is like really trying to make the most open source version of hormones. So it's a really cool project. So we did a joint residency together in Barcelona at Hangar, a great, great place. And we were just kind of exploring these different relationships that, these different entanglements that humans have with this specific species of mushroom called white rot fungi. So these are the kind of mushrooms that you see like mostly growing on a tree that's like dying or dead, because they have these enzymes that can digest the cellulose of trees. So, and then we were also researching like other properties of the mushroom, like these anti-cancer properties, anti-thrombosis properties. We were trying to grow the mushroom in urine and coconut water. Like we were just like playing around with all these different entanglements that the mushroom has to offer. And another really fascinating thing is that one particular species called Schizophyllum commune is actually the most commonly occurring mushroom in the world, most commonly occurring species of mushroom in the world. And it just so happens to have more than 22,000 different sex variations, which is like super, super queer and very, very interesting compared with humans who only have 2. So, okay, so why are the mushrooms able to digest plastics? Okay, so this is pretty interesting. So on the left side, these are examples of some common plastics that are in the environment today. So polyethylene, PVC, you know, so these are all really common plastics. And they all kind of have this like polymerization structure. Like it's like one monomer that gets like combined into like a chain, right? And so on the organic side, on the right side of the screen, you see like cellulose and lignin. So these are like naturally occurring forms of carbohydrates or starches that you see in the environment. And you can see that this same kind of like polymerization is happening. So the enzymes are able to digest the cellulose and lignin, and they're also able to digest the synthetic polymers because of these shared characteristics and structure. So that's why I find these enzymes super fascinating. It's, again, this kind of like happy accident of like, you know, an organism that didn't necessarily evolve to be digesting plastic, but because the plastic is so pervasive, maybe there is an evolution that's happening, an evolution that's making the mushrooms more resilient in a toxic environment. So this should be an animation. Okay, so let's see if I have the actual copy here. So from this residency, we decided to create a zine because when I talked about knowledge production and also alternative ways of practicing science, I think that part of it is also the way you disseminate science and disseminate your research. So of course, like as an independent artist or as citizens or hacktivists, of course, like we're not going to do it the traditional way of publishing a scientific paper, but we're going to make zines. And zines are really fun to make, and I have a huge zine collection here. I'm going to try to find this mushroom zine. Yes, okay. So this was designed by Ryan. It's a really awesome newspaper zine. So there you have it printed. Wait, can you all see my camera even though my screen is there? Yes, right? Okay, just checking. Okay, so, and then in the back, you have all of this different information that we compiled together about all the sexual variations of the mushroom, and then the anti-cancer properties. And then it also talks a little bit about the experiment that we're going to do today, which is the decolorization experiment. So this is really cool. I can share the PDF of this later. Actually, I want to compile all this information I'm giving you and like make it a nicer format for everyone so I can share it easier. Let's see, now going back to presentation. Okay, so when we were at this residency in Barcelona, we also experimented with this solid phase extraction. So I showed you before these peristaltic pumps. So these are also used in the making of the xenoestrogen cocktail. And we performed this workshop for the first time in 2017 in Zurich during a gender hacking festival, which is super fun. And you can see the messiness, you can see the peristaltic pumps were used to make this xenoestrogen cocktail. That's Ryan right there. And this is me. I think I was like 5 or 6 months pregnant during this workshop, and I was so paranoid because I was like boiling plastics, and I was like, okay, I really don't want to inhale this. It could be so bad for the baby. But no, it was a really fun workshop. My child came out fine, fine and healthy. Yeah, so then we boiled plastics. We had like a bunch of cosmetics and soaps that were donated by people. Here's like nail polish, more plastic bottles, shampoo, and we just did like a very informal extraction because we didn't find any like formal protocol published in a scientific paper of like how to separate out the xenoestrogens from your cosmetics. So we just kind of like did it like in the kitchen way. So we would like smash up the cosmetics, like make them as liquefied as possible, And then like we ran them through these filters, and then we eluted them with methanol. And yeah, this was like the very like improvisational part of the workshop, but it was fun to like experiment and play around with other people. And about 2 weeks later, everyone kind of shared images of their Petri dishes, because we inoculated these dishes. Yeah, okay, so why are the dishes blue? Okay, so the experiment that we performed, it's a basic decolorization experiment that we found online in the scientific journal. So a lot of papers that we found, a lot of them coming from Asia, actually. So hard to focus this, okay. So here are the plates that I prepared. Basically, I did a malt extract solution with agar, and the blue is coming from this bottle right here, Remazol Blue. Shout out to Chris and Regina from Art Laboratory Berlin. They sent this to me because I had a previous exhibition using this bottle of blue. So this is Remazol Blue, abbreviated as RBBR. So this RBBR is the same or similar compound that they use to make blue jeans. So blue jeans, that ingredient to make blue jeans is actually a endocrine disrupting compound. It's fine if you wear it. I think it's fine, but the problem is a lot of these blue jean factories, if they're like located, if they're like not taking care of their waste, then a lot of the RBBR, it does go into the environment, it goes into the rivers, and it's not really nice for the organisms. So because this is like a synthetic compound that is a xenoestrogen, then this scientific paper decided to put this into the agar as a way to visualize the activity of those enzymes. So here's a dish that was also sent to me from Art Laboratory Berlin. So these are oyster mushrooms, which fall under the category of these white rot mushrooms. So oyster mushrooms, as you know, are completely edible. You find them in the supermarket. And when I turn the Petri dish around, you can see that this color is no longer blue. Now it's like an orangey color, but it used to be blue. So you can see that over time, the mycelia, as they grew on the dish, they really did digest the RBBR. So all of these dishes that I made today, we can expect them to turn the same color as this dish that was sent to me by Art Lab Berlin. So the experiment that we are performing today is not only the decolorization experiment, but we're also going to do a test, right? So the control that we're going to do is basically just the RBBR with the mycelia growing on top. The experimental portion is going to be the same factors, so RBBR with the mushrooms, and then we're going to add the xenoestrogen cocktail. And the reason why we're doing this is that we're going to compare the speed of decolorization between the two dishes. And the hypothesis that we have, that me, Ryan, and Paula, like we came up with this hypothesis that probably the mushrooms with the xenoestrogen cocktail will decolorize faster because those enzymes are getting like an extra activation from the presence of those molecules. So that's the hypothesis. It's really interesting to test out because we're basically testing out the evolutionary survival of these organisms. It's pretty fascinating. It kind of gives you a narrative of multi-species survival. There's organisms that are able to shift easier in these toxic climates. Other organisms shift easier than others, but these mushrooms, they definitely give a narrative of hope. So just a couple of images. I used these mushrooms in an art installation I did in Indonesia, part of a 10-month research residency there. So here's a close-up of the mushrooms. They're growing. So this bamboo sculpture, it's replicating a river that I researched in Indonesia. And I filled with the same agar, this RBBR agar. And then I have these mushrooms kind of encapsulated in these petri dishes. And the dishes, like, they did decolorize over time. So it was nice to see during the duration of the exhibition that the mushrooms, like, they grew, they completely colonized the whole dish, and then they decolorized the dish, and the agar itself got super nasty because there's a bunch of contamination, and then it got dried up as well. So that was really cool to see that effect. Here's another, this is the same installation that I did it in London. So we actually shipped everything from Indonesia to London. And then lastly at Art Laboratory Berlin. So the reason why I'm showing these installation images is because I think that the hacking is not just like techno-scientific, like how I said before, but I think these hacking workshops, you know, it's also a way to inform your own artistic practice. If you are an artist and you're it's like working with any other medium, artistic medium, like whether it's like you're painting or you're sculpting or you're filmmaking, you know, this is just another medium, and working with the material, of course, will inform your practice. So I don't have images right now, but, you know, from this urine hormone extraction protocol, I've made like performances and also films, like speculative fiction films and other workshops, like out of this one protocol. So I think it's really interesting to see when you do perform a workshop, you gain this intimate knowledge around that material. And in this case, my material would be hormones. And I think it has been a really, really interesting methodology for me as an artist who does a lot of research first, and then I make like a sculpture or something afterwards. So those are the end of my slides. I think that I just gave you a bunch of like important information, and that's what I wanted to do first, because now the kind of pace of the workshop is going to slow down a bit. So I'm going to be doing more like more tactile stuff. It's going to be really chill. I'm not going to be talking the whole time. I'm just going to be doing. I'm going to try to explain every step that I do. And feel free to stick around, or if you want to leave, that's also fine, because I feel like I gave you all the important information already. But yeah, I'm just gonna like have a chill session right now, like in my flat. Too bad no one's here. And what I'm gonna do is I'm just going to plate these mycelia onto these dishes, and I'm gonna, oops, wrong, okay. And I'm gonna do my best to perform a sterile technique, although I don't have access to a fume hood right now. Because normally you would do this process inside a hood where like all the air is being like sucked out. So I don't have that here. So instead I'm gonna use an open flame and some isopropyl alcohol. So this is kind of like the less, it's like the more ghetto way of plating, inoculating your petri dish with mycelia. But yeah, some contamination. Oh yeah, yeah.
Mm-hmm. Of your presentation, if you have finished with it, so I can show big screens.
Oh yeah, sure.
Thank you.
Okay, so yeah, so I think I'm. Oh yeah, and does anyone have questions before I start doing this mushroom stuff? And feel free to just talk directly into the microphone if you have a question, or you can type it into the chat box.
Hello, Mary. Thank you for your presentation. I was wondering what are the open and free resources to learn more about these experimental processes?
What are the other protocols? Is that your question?
I was looking for like any open resources that you can suggest us to learn from.
Yeah, let me copy and paste some links from my website. So I tried to put my all my protocols on my website. It's a bit messy, but that's just my version of a scientific publication. There's also a really nice wiki on the Bacteria website. You can also paste that. I can take another question in the meantime as I'm like copy and pasting these links. Okay, here's the website of Brian Hammond. You can find open source gender codes there, maybe. Okay, here's open source gender codes. Yeah, let me look for, am I able to attach PDFs to this platform, or does it have to be emailed or something? Do you know, Ekmel? Shared notes? No. I don't know if it's possible to attach documents.
I think you should be able to put it on shared notes just by dragging your PDF.
Oh,
And
okay, let me try that.
I was also wondering if you had faced any like censorship or like protests about like from the institutions or from people.
So far, no. No, I don't think that we've had any, like, you mean getting in trouble with the law or getting in trouble with the government or like getting bad press in the media? Is that what you mean?
Kinda. I mean, I don't know, like from religious like communities or something. I don't know. I was just thinking about this and was wondering if it was if there's an issue.
No, I don't think so. I mean, like there is some of the workshops that I've done, they do seem a bit risky. Like one time I did a workshop in Hong Kong where we did the urine hormone extraction workshop, and we actually, because we're in Hong Kong and we're kind of making a critique on the beauty culture in Hong Kong, we decided to extract the hormones from a friend of ours who used to be a former beauty pageant. And so we kind of did this performative thing where it's like, oh, she's a beauty pageant, so she must have like the superior estrogens in her urine. So we decided to like take her urine, extract it, and then we made a face cream from it. And then we had like 15 or 20 people in the audience, and then we took turns, like, you know, putting the cream like on the face and everything. And then one guy, he put a little bit on his arm here, and then like about 30 minutes later, he actually had this like yellow discoloration happening on his arm. So that was like that was something we didn't expect that would happen, but it wasn't like painful or anything. And so that was like one kind of reaction that I saw from working with the hormones. It's really hard to really track, you know, when you're being affected by hormones, you know, because the effects can be very sudden, like it can be like that, you know, because we do have estrogen receptors in our neurons. But the effects can also be like very, very long term. Like if, let's say you're like a pregnant mother and you get exposed to plastics, you know, you don't see the effects maybe until after your child is born. So it's really, really hard to track changes. It's really hard to track negative effects. And that's why we have this term slow violence to describe this endocrine disruption. So yeah, we do some risky stuff sometimes. Like another time we decided to take these hormones that we extracted from urine, and then we dissolved them back into vodka. And then it was after like an 8-hour workshop performance, and we decided, okay, so now we're all going to take a shot of this estrogen vodka. And, you know, we gave everyone a shot and we took it together. And as far as I know, like nothing bad happened, but it was definitely kind of like a risk. But we did it as kind of an exercise of consent. So are there any other questions?
That was
from
very
people?
interesting. Yeah. You should have maybe left one person who didn't drink, so that if anything happened, they could say.
No, there were definitely some people who decided not to do it. It was mostly like us, like because it was part of a collective of us. There were 5 of us that were performing as like the aliens in green. So we were performing, and then so we were the ones that suggested, okay, everyone take a shot. And then I think only like 2 other people decided to join with us, and then the rest of us, it was just us. So, but yeah, it can get risky, of course. But I think in a big bottle of vodka, it's so dilute that maybe it's the quantities are so small. But yeah, it's definitely a risk. I don't know if it would be that much different from like drinking your own urine, for example. So I guess I didn't really see like as a huge risk. I was trying to add the PDF, but it didn't work. I tried to like drag and drop into this shared notes, but it didn't work.
If you want to share it, maybe you can send us and we can put it on the website.
Okay, sure. So I'll email you the PDF right now. Are there any other questions while I send this email? Okay, so I think I'm just gonna start. So let's try to get a better angle. I also want to give a shout out to my friend Alessandro, who's in Berlin right now, and he's part of Top Lab in Berlin, and he was super helpful in kind of walking me through the process of sterilizing with the pressure cooker and how to prepare the plates. So okay, let's get a good camera angle. Whoops. So when I prepared the plates, I didn't really do anything super fancy. So anyone can just try this at home, actually. I'm going to show you in a second the ingredients that I used. It's very easy to find. Hope this doesn't keep falling. All right. So, so what I did was I found some malt extract from a health food store. So that's what the mushroom likes to eat. And then I also found some agar, also from a health food store. And let's see, agar. And then here's the RBBR. This is probably the most fancy thing in this experiment. But if you wanted to just grow mushrooms without decolorization, then all you really need is the malt extract and the agar and water. So it's super easy. I borrowed a pressure cooker from my friend Gunther. So shout out to Gunther. He is a bioartist based in Vienna. And with this pressure cooker, this is basically replacing an autoclave, which is what they use in the laboratory when they want to sterilize any kind of dishes or anything. So let me just grab the glassware. Okay, so I did something like this. So I just took a jar that I recycled, and here's like the rest of the RBBR solution. It's already dried up because the agar solidifies when the temperature cools down. So all I did was I mixed 5 grams of the malt extract. Ideally, you would find it in the powder form, but I only found it in the liquid form. So I did 5 grams of malt extract, then 5 grams of the agar. And I calculated like 0.1 grams of the RBDR because it's very, very concentrated, it's very strong. I mixed it up, I put a foil over it, and then I put it in the pressure cooker. And I let it cook for about 40 minutes. And afterwards, I poured the dishes. These are glass dishes, and they're very heat safe, so they're meant to be autoclaved. But I didn't want to put these plates in the pressure cooker because I didn't want them to be like shaking inside and breaking. So what I did was instead, I just cleaned them. I wiped them down with this isopropyl alcohol, and then I put them in the oven at the highest heat for about 30 minutes, 35 minutes. So I've never done this way of sterilization before, so we're gonna see if we get lots of contamination or not, because I'm really not sure. So yeah, so now this is kind of like the mother plates. This is the mother mycelia that we're going to transfer onto one of these plates. So when you're doing the experiment with the xenoestrogen cocktails, I don't have a cocktail today because actually I was hoping to do this part with the other participants, and we were all gonna bring some toxic ingredients. Like we were gonna bring cosmetics and plastic bottles, birth control pills, but I wasn't able to source those things because I can't have anyone in my flat right now because of Corona. So I will try to make my own cocktail like later on. And so I will do that cocktail portion later. And we're still gonna have a follow-up session on the 23rd of April. So maybe by then we can see some results. If not, we can always postpone it a little bit later, or I can share images of the results later on because I don't have the cocktail prepared today. But today I can just show you a really basic technique for inoculating your Petri dishes. So light this up. So when you have an open flame, it just kind of sterilizes the air around it. So you know that this area around the flame is safe to work with. Okay. Just have some candles here. All of these plates have been wrapped with this stuff called parafilm, which is kind of like saran wrap. And I wrap them so that they're airtight, so there's no contamination inside. You don't want contamination because it could potentially compete with your mushrooms, and you don't want that. Okay, so got some gloves. So some people, when they're doing like a workshop with many people and like everyone takes turns to take some mycelia, some people will actually like draw a grid onto the dish, and so it's easier to just like pick out those tubes. I mean, why did I say tubes? Cubes. But what you would do is you would actually cut into the agar because the mycelia grow into the agar. So to get a really good sample, you actually have to take some of the agar. So to perform this, I'm going to use something like a knife like this, like a scapula. scalpel, not scapula. I think scapula is something else. Scapula. Okay. So this one I did not put in the autoclave, but I think I'm just going to use isopropyl alcohol and fire to sterilize it. And always, always, always be careful with alcohol around an open flame because it's very flammable. So I'm just gonna wipe this with the alcohol. And put it into the flame. I guess you can't really see the flame because this light is too bright. Is that better? Yeah? Okay. Yeah, I think you can see it better now. Okay, so open this now. Okay, so every time I open the Petri dish, I'm gonna open it like so slightly and always, always, always as close to the flame as possible. Just gonna grab some other things really quick. I want to make sure this process is as sterile as possible. I also rubbed the alcohol all over my gloves. so paranoid about contamination. So I can't touch my computer now because I just sterilized everything, and I can see that in the chat there's like 4 messages, but I can't see the messages. So if it's something important, please just turn on your microphone because I can't touch my computer right now. Okay, I'm gonna go in and just cut a cube from the dish. I'm just gonna take the parafilm off this. Use this. I made about 15 plates, but I think I'll only do a couple of these today. Okay. It's probably a really big piece. Just put it in the center. Okay. So it's something like that. So I'm gonna try another dish now. So in the workshop, normally I would have each person take turns making their own dish. And I was gonna have everyone go home with their own dish and observe the mushroom. I'm going to sterilize between plates. Okay, here's the second plate. third plate. Actually, I'm going to fix the first one that I made because I don't think it went deep enough into the agar. So this is also the process you would do if you wanted to keep like a live culture of mushroom, like if you wanted to keep it going. Because sometimes like plates, like they run out of nutrients. And so you don't want the mycelia to get old and dried up. So this is something you would do to replate the mycelia so you can continue to have it. So I think like keeping these organisms alive is kind of like if you had like a pet or like a house plant or something, you have to always feed it, keep it healthy, keep it alive. I actually should have worn a mask while doing this because when I'm breathing, I can accidentally breathe some stuff. Here's the fourth plate. So it's good to kind of get the mycelia like stuck into the agar itself because that's where the nutrition is. So I'm just gonna do one last one. I think 5 is a good number. Maybe 1 or 2 of them are gonna come out contaminated because our technique is not perfect. Okay, here's the last one. So now I will wrap these. So to wrap them, I will use something called parafilm. So I just cut a strip like this. So for the mother mycelium, I'm going to put this back into the fridge because I don't want it to grow. So I think it's already like really overgrown its environment. So I don't want it to grow anymore. So I'm just going to keep it in my fridge, and that's going to slow down the growth. And as for the rest of these, I actually do want them to grow. So I'm just going to put them at room temperature. Or maybe in my closet where my water heater is, because that's the warmest part of my flat. And I think they're gonna like that warmth. They might grow faster. When you're setting up the plates with the xenoestrogen cocktail, you want to put the cocktail in on the plate first before the mycelia. So you could take like a syringe like this, and from your cocktail, you just maybe you put like 1 milliliter or something on your plate, and then you put the mushroom, like how I did today. Okay, so that's finished now. So I can touch my computer now. Any questions? Okay, so there are some questions. Sorry, I didn't see them. What about masks? Now in the pandemic time, could mushrooms be able to disintegrate masks? Are the masks made of plastic? Rodolfo? I don't know if he's still here. I think Rodolfo is typing right now. Oh, medical masks. I don't know. I mean, you'd have to try it. You can try to inoculate. You can try to like put the mask or try to inoculate a mask with the mushrooms in a sterile condition. I don't know. How can we make the cocktail? Can we buy the mycelium online? Okay, so the cocktail. So I'm using these peristaltic pumps. But if you don't have a peristaltic pump, well, these are really easy to find as well. Like they're just on Amazon. I can probably just send you a link right now. Yeah, this one looks pretty good. Okay. So you can use the pump with the C18 cartridge. Now, these are probably harder to find. Maybe let's check eBay. C18 cartridge. Whoa, so expensive. So expensive. Maybe it's a big pack. 110 euros. And there's only 2 inside. What? That's crazy. No. Okay, so each one should not be more than $2 or $5, I would say. Maybe eBay is not the best, but let me just send you a link to this brand right here for AccuBond. But I mean, if someone wants to try this, I can always just send you in the mail, you know, like traditionally, you know, biohackers we're always sending each other resources through the mail. I mean, that's how I got the mycelia, that's how I got the RBBR. So just let me know, I can send you some of this stuff. The peristaltic pump needs to connect to a microcontroller like this. And you're gonna need some of the silicone tubing. So the flexible one, not like the hard one, PVC kind, so the flexible one. And the cocktail is really like, it's up to you, like how you want to creatively make it. You can make a cocktail of like many different ingredients, or you can just focus on one ingredient. Maybe you're really curious about the relationship of fungi and birth control pills. So maybe you only do birth control pills and you give it to the mushrooms. if you wanted to do birth control pills, it really depends on the thing that you're working with. So birth control pills, you can smash up the pills and you can dissolve it in alcohol, like you can use isopropyl alcohol, you can use ethanol, or you can try to find methanol. Methanol is a little bit hard to find because it's a very dangerous ingredient. But methanol is basically that ingredient. Whenever you're doing like an alcohol distillation, if you're making like vodka or something, the methanol is always the first layer of your extraction, and that's the stuff that you want to throw away, because if you accidentally drink methanol, you can actually go blind and you can die. So the methanol is kind of like a dangerous, more controlled substance, but it's also flammable. But you can always use like ethanol or isopropyl alcohol as the as an alternative option. However, once you have, okay, let's say that this is your, let's say these are your birth control pills already dissolved in the methanol. You don't want to give methanol directly to the mushrooms because it is very harmful. So what you would do is you would allow the methanol to evaporate, and then so you only have the hormones. But maybe if you're working with birth control pills, you can skip that step, because I know birth control pills, the main ingredients should only be the estrogen or progesterone. But I guess there's other ingredients in the pill that make it solid. So obviously you don't want that in your cocktail. So, okay, yeah, so you would use the methanol, let it evaporate, and then redissolve it into something that's safer for the mushrooms, like DMSO is one of them. Maybe even isopropyl alcohol would be fine for the mushrooms. Oh, cool. Thanks for posting that link, Rodolfo. Yeah. Yeah, it's not super expensive. 1 liter is €7. Cool. And then DMSO. Okay, so DMSO is pretty good for any organisms. It's good for yeast, it's good for mushrooms. Ooh, have it on Amazon. Okay, cool. So you can buy this on Amazon. All right, so that's DMSO, and then you can just take like 1 milliliter or 2 milliliters of your DMSO plus xenoestrogen cocktail, and just like spread it on the plate. You can use something that's like kind of more of like an L shape, so like an L shape like this, and you can like spread it around the plate so it's all even in there. And then after that, you just proceed with the step of inoculation. So yeah, there's some special stuff that you need, but it's possible to do on your own. See if there are any other questions. Okay, I missed this question from Elif. First of all, thank you so much. I wonder if there is a theoretical flow in your arts practice that takes you to mushrooms. I think that it was more, I started with detection. So being able to visualize these invisible molecules. And then from detection, it was like extraction. So, okay, how can I extract these molecules? Now that I see them, how can I extract them? And I think after extraction came bioremediation, which is, okay, so how can we decolonize our bodies and our environments? So I think that was kind of the flow of my hormone hacking protocols. Next question. Type the name of the dye. Yes, okay. So today we are working with oyster mushrooms. And the blue dye is called Ramazan blue or RBBR. So let me post a protocol. So let's say you find the mushroom, like let's say you're hiking in the woods, in the forest, and you find the mushroom growing on a tree. Or let's say you're shopping in a supermarket and then you find the mushroom like in the supermarket. So how do you culture it into mycelia? I can post a really great link that was created by Ryan Hammond. They posted it on Instructables. So this is a really thorough protocol. Also goes into like sterile technique. So I would really recommend reading this through. Ryan actually found some Schizophyllum commune, which is the other species that we worked with. Let me type it in here. Schizophyllum. Okay. So in this Instructables page, Ryan found these mushrooms on a tree and made these agar plates. But instead of MEA, I think they did use MEA. They used malt extract, agar, and what did they do? They also used a pressure cooker to sterilize. So I think they just grew the fruiting, they cut a piece of the fruiting body and just grew it on the dish. But there's a way to do it where you have to cut the fruiting body in a way that it's like the core of the mushroom. You know, like you don't want to get anything from the surface of the mushroom because it's probably contaminated. So you want to cut away like everything that you only have like the core, like the inside of the mushroom. And so that's what you would plate on the petri dishes. So that's a really good resource. So I recommend looking through that. And some other like common, people also use like PDA, which is potato dextrose agar. For whatever reason you can't find malt extract, you can try potato dextrose. But that one kind of involves like boiling a lot of potatoes, and it's kind of takes a lot of time. So if you can find this malt extract, then it's much easier. Oh, really? I never tried using dog food. Is there a specific brand? Because so many different kinds of dog food. Okay, so any kind. Okay, there's some questions I missed. So this user uses light projections in their art, projecting light through, recommend one setup in particular. Projecting lights like through the petri dishes? Projecting. What do you want to project on the projector? Sorry? You could use something like you can use a webcam microscope and connect it to a projector maybe. I think that would be kind of cool. because it does look beautiful when they start to like grow out from the center. It looks really amazing. Menstrual blood. Do you give the menstrual blood to the mushrooms? Or you're projecting the menstrual blood? Okay, Marissa asked, how do you come about working and creating different protocols? You know, I read a lot of scientific papers. Well, first if I have a question about like how do I extract this, then I will look through lots of scientific papers, and usually I will call up like a biohacker friend or a scientist friend who knows how to read these papers, because it's really, really hard. Even as someone who, I did take lab classes when I was studying in college, and it's still really hard to read these papers because there's so much like scientific jargon that you're just not used to. So I will ask like a scientist friend, like, what does this mean? How do I get this ingredient? There's some scientific papers that are published in a way where it's like following a recipe, like a cooking recipe. Like for example, on like Nature Protocols or something, then those papers are written like in a way that's easier to understand. But I looked through scientific papers, I asked friends like what's going on, and then yeah, I post a lot of questions on Facebook and stuff like that, because usually like a lot of people will respond, like people in like the biohacking network, like they have some ideas. So I think it's really, really cool to be asking these questions within like within a network or a community. So another thing that I used to do before the pandemic was I used to go on a lot of like hacking residencies with friends, like people that like I only met online, and then I would meet them in person like during a residency, and we would just like hack together for a week or for 2 weeks and do something artistic at the same time. Or yeah, and so I think that's one of the main ways that I create these protocols, and then when I make it into a workshop format, then this makes it like, then I keep repeating the same experiment over and over again, and you know, sharing and teaching is also a form of learning. So yeah, I would say that that's kind of like my main methodology for coming up with these protocols. Have I ever used menstrual blood in my workshop? No, but I did like a hacking experiment once. Yeah, we were curious about how sperm travels in menstrual blood, because menstrual blood has like a lot of hormones, and then sperm are able to like locate. They have this motion with their tail that they're like going like this, and they're trying to target in on a signal or something. So I did like a little experiment like that before, but I never did a workshop with menstrual blood. Are there any other questions? I just see some people typing, so I'm gonna leave a couple of minutes open for questions. Do you link queering and this type of fungi growth? Are you asking if the queering properties of the mushroom have anything to do with the growth of it in the presence of toxicities? Okay. It's funny because someone else asked me this question recently. I think the fact that the mushroom has more than 22,000 sexual variations, I'm not really sure if that's connected to its ability to digest toxicities. Because all I know is that it's the enzymes that are able to break down the plastics. But it could be that having so many sexual variations allows it to have more diversity and maybe more ways to adapt to different environmental conditions. Or maybe because it has so many different sexual variations that it's able to, you know, to recombine sexually, like exchange genetic material and basically select for the most superior genes or something. So that's something that I would speculate about, because, you know, if you have so many variations and they're able to like sexually combine, then you would produce even more variations from that process. And the more variations you have, then the higher chances you have of surviving in a high pressure environment. And that's kind of why you know, having all these monocultures in the environment is like super bad. You're reducing the species diversity of a certain area. So, you know, in areas where like only one type of tree grows, if there's some kind of virus or fungus that comes around and kills that one species of tree, then and they're all clones of each other, then the whole population is going to die out. So I think it's good to have as many sexual variations as possible. I'm curious about what we expect to see on the 23rd of April. So I will, sometime this week, I will try to make like a cocktail, or maybe I'll just use birth control pills if I can find any. So if there's anyone in Vienna who's listening right now and they have birth control pills to give me, please text me. But yeah, I think I'll make a cocktail, and then I have 5 of these plates already made today. And I think I will do 5 more plates with the cocktail. And what I'm going to do is, I think like maybe every 3 days or something, I will take some pictures, and I'm going to track the growth of the mycelia. And I'm just going to compare like the ones with the cocktail and ones without the cocktail, which one is kind of decolorizing faster. So we can have a session on April 23rd. Like we can all like join in on the discussion. Or if it's easier, I can also just send my photos to the Amber Festival organizers, and they can maybe post them on the website or something. But it's basically an open session. Like we can just like, I can show you my results. Because originally we were going to have, you know, live participants, and so everyone would share their plates. You know, I was imagining that on the 23rd, like we all hop on video call, we all show our plates like this. But since I'm the only one doing it, we could have a session together, a video session together, or I can just post the pictures to the organizers. One last question from Marissa. Do you think these kind of biohacking, bioart practices can have an effect in future self-healing or future medicine? There's a lot of current biohacking practices that are about medicine, like DIY medicine. I've met biohackers that have treated themselves from chronic diseases, like a chronic disease like IBS, for example. I've heard of biohackers like really trying to find a cure for their own diseases or their own issues. So I think the field of DIY medicine is it's already happening. Like it's already, there's a lot of talk about like customized medicine, for example. So you know, if you track your own body chemistry like really well, like let's say you're testing your urine like every single day, like if you have all that data on yourself, then you don't really need to go to a doctor. You just need a way to interpret that data. And you know, with the internet, you can find all the information that you need. You can email anyone that you want. You can email experts, and you can figure out how to interpret that data, and then you can be the master of yourself. I mean, that's what the field of DIY medicine is proposing, or like customized medicine. Yeah, and then there's also like apps. You know, if you think about like for women, they have like ovulation trackers. You know, like there's many ways to kind of to check up on your own body regularly. There's like, you know, the Fitbit or like Apple Watches, or like also tracking your heart rate and your everything, you know, all your health data. So I think it's definitely like an exploding field, you know. Like I've heard of like smart toilets that are like also analyzing your poop, and yeah, there's like so many examples. It's definitely a really big field. Yeah, and so like biohackers, like of course there are biohackers that are really interested in that topic, and then they try to find like more accessible and more cheap versions of that technology. Oh, what is levothyroxine? Thyroxine. Thyroid hormone. Ooh, I don't know anyone who's doing that right now in the biohacking or bioart network. I know people are trying to make insulin for people who have diabetes, but I don't know anyone who is trying to make thyroid hormones. But that's very interesting. For hypothyroidism. Okay. Yeah, but that would be really interesting. Yeah, I mean, you know, when you're not able to synthesize it, the next best option is try to extract it from a source. So yeah, maybe there's like animal products. I'm sorry for anyone who's vegan or vegetarian. Maybe there's animal products where you can isolate or extract the thyroid hormone, or yeah, I don't know. You can get really creative with the sources. There's certainly a lot of bioethical questions associated with that, but that's pretty interesting. Is there anyone trying to go into treatment process, HRT or gender transition using one? No. Okay. I'm glad that you asked this question because I think that, for example, my protocol for extracting hormones from the urine, I made this speculative fiction film about it called Housewives Making Drugs. I can post a link to it, and it's a comedy in a way. It's about like trans women in the kitchen, teaching the audience at home how to make estrogen in the kitchen, and they're using the urine hormone extraction protocol. And I was worried that people would think it's real. So, and I don't think people would think it's real because it's a satire. It's like a fictional cooking show. But then I was still kind of paranoid that people would think it's real. So I wrote this. I had to write a disclaimer to people and say like, wait, am I searching? I had to write that it's very, very difficult to isolate only estrogen because in this protocol, you're getting a collection of molecules that are similar to steroids. And steroid molecules, they all have this like 6-ring carbon structure. And that makes it a very like fatty molecule. And what I mean by fatty is that they're non-polar, which means that they don't like water. They repel water. So it's like oil, like, you know how oil and water separate. So something that is non-polar is like, it repels water. But if you look at the hormones, they also have these side chains. And these side chains, usually it's like an OH bond or something. This makes it actually able to dissolve in water. So it makes it like water. So that's why, you know, if someone's on HRT for, let's say, like testosterone, sometimes like they'll have like a patch that they just put on their skin. And that's because the hormone, like, it's able to just pass through your skin barrier. Like it can just pass through your cell membrane. At the same time, you know, lots of hormones are also carried in the water, you know, so that's why like microplastics exist like in the riverways, whatever. So so it has this kind of dual property. So I forgot why I'm explaining this. What was the question again? It was like anyone trying to get treatment, and then housewives making drugs, and then okay, yeah. Okay, so then so then you have all these hormones that are collected in the urine extract, and it's like, but then if you're trying to gender transition, you only want one of those hormones. You ideally want, like, if you're trying to become female, then you would want to have estrogen and a testosterone blocker, I would assume. And I think that using that urine extract is not the right way to go. And especially because you're doing it in a DIY setting, you are not able to really know if you extracted the right thing. You know, like in the laboratory, you would have these machines that would verify that you have this and this only. So there's no way to verify that in a DIY kitchen setting. And then there's also like impurities and other contaminations that can happen. So I really would not, I would never tell someone to use that method for HRT. And also another reason is because the hormones that come out of the urine, they get processed through your kidneys. And your kidneys actually, they do something called conjugation. They add something to the molecule that makes it inactive. So you would need an additional enzyme to reactivate or to deconjugate those hormones. So yeah, there's many reasons why that protocol would not work for gender transition or HRT. Any other questions? Yeah. No?
Yeah,
I think your sound is on.
I did so, yes. I mean, I'm just asking if there were any other questions, or are we coming to an end, or...
Yeah, we have about 15 minutes left.
Okay, if there is any questions, you can turn on your camera and you can talk, continue. And it turned out to be a kind of discussion among more kind of professionals or bio artists, so that's also possible to continue that way.
I think I'll just leave my. I'll still be here if anyone comes up with a question later on, because I know it's like a lot to reflect on, and yeah, I can stay on until the end of the session, until 3:30.
Okay, as you said, I mean, the participants can share the photos and other documents, so we can upload them to the festival's page and on your workshop site, which I already uploaded your PDFs you sent. They are now there, so they can be accessible. And yeah, we can add the photos there too, or other material. And also the video of this workshop will be there too. I mean, the YouTube stream also will be there. Are you gonna
Oh, there's a question.
Oh, sorry.
Yeah, the decolorization process. I kind of see it as a metaphor for decolonization. You know, like as the blue color is disappearing, you know, you kind of have this metaphor of the toxicities disappearing, and the kind of, you know, growth of the mushroom. You know, so um, it's kind of like a bit of a utopian narrative. You know, like I just have this vision of um, these mushrooms growing in all of these toxic waste sites, you know, like these areas that have been subjected to toxic dumping, and then I just imagine like these mushrooms are growing, and it's kind of like it's very utopian, I would say. But I think we need more stories like this that are more about resilience and adaptation and survival and doing it in a multi-species way, in a very queer way. Because right now the dominant narratives and the dominant stories are very apocalyptic. You just look at any Hollywood movie and it's like extremely apocalyptic. And this is um, it's just selling you like fear and panic. But then we need actually stories about hope, because, you know, actually we have to be very, very creative to come up with solutions, right? We have to like really think like outside the box, like, okay, what is the best strategy for surviving in this planet together? And, you know, you can't be creative if you're full of panic. I think a lot of us are experiencing this, you know, like since the pandemic started, because we're constantly hearing bad news. Like we're hearing lots of stories about Black and Brown people getting murdered and all of the inequalities that are coming out of the pandemic, people dying, government failing their people. And then when you have like all of this panic, it's really hard to access your creativity. And I know like a lot of my friends and myself included, you know, it's kind of like this, what do they call it? Doom scrolling, like when you're scrolling on the internet for doom, you know. So lots of people that are doing this like doom scrolling, um, it puts them in a really bad place mentally. So I think that storytelling is really important. I think it's really important what kind of narratives and fictions you choose to spread or to include around you. Yeah, I think these times are really, really tough right now, and we can't get through this alone. We have to get through this together. So I think that storytelling can really bring us together in this way.
Yeah, it's really great. I really totally agree with this. Like the magic that comes from this kind of narratives, kind of new mythologies. So it's really, really good to hear you talking about this. Thank you.
No, thank you. Thank you for your question. I think that was such a great way to end the workshop, actually, because we are ending inspired by this mushroom and all of its queering and healing properties. So I think this was a really, really nice way to end.
Okay, thank you very much, then, Mary, for this very inspiring, very informative, and thoughtful workshop. Are we gonna have another session on 23rd to check out the results as planned already?
I mean, maybe we don't have to, because I can just send you photos because
Yeah.
I don't have live participants this time. So maybe I can just send you photos and you can post it on the website.
Okay. Okay. Then we are canceling that in the program. And thank you very much. It was wonderful. And thank you, all the participants.
Yeah, thank you. Thank you everyone for joining. And everyone, please stay safe out there. I hope we
I
can
hope
all
you
meet
too.
each other in person one day. Thank you. Thank you, everyone. Yes, take care. Stay safe. Okay, logging off now.